In this problem, we have to calculate some limits. And we have to do that simplifying common factors in the numerator and the denominator until we can calculate the limit easily. This is the first item in this exercise. As you can see here, this is the very definition of the derivative of the function x to the n at the point A. So actually what we want to calculate with this limit is this number here. But we're not going to use this this idea because so far, I mean, in the calculations of limits of this problem, we don't have this tool. We don't have the derivatives. And actually, many of the derivatives that we can calculate are because we are able to calculate this limit here. So we're going to do this with just algebraic methods. So in particular, for this one, the result is easy because there is an well-known identity which says that x to the n minus a to the n is equal to x minus a times x n minus 1 plus x n minus 2 times a plus x n minus 3 times a squared, and so on until you get to a n minus 1, right? And this is what we're going to use here. So if we divide by this factor both terms, what we have is that x to the n minus a to the n divided by x minus a, which is actually the limit we want to calculate, is equal to this polynomial, xn minus 1 plus xn minus 2a plus and so on, plus a n minus 1. Now the question is, how many terms are there here? Well, it's a polynomial of degree n minus 1, so it's got n terms. So this sum contains n terms, right? So if we calculate the limit of that polynomial, which is actually the limit we want to calculate, right? Let's say the limit of this, the limit of x to the a, x n minus 1 plus x n minus 2a plus so on, right? x a n minus 1. All we have to do is to substitute x by the value of a, and we're done. And this would be a to the n minus 1 plus a n minus 2 times a plus a n minus 3 times a squared, and so on until we get to a n minus 1. But if you add the exponents here, this term is just a n minus 1, and so is this one, and so is every one of the terms that appear here. So we've got n times, because there are n terms, equal all of them to the same factor, which is a n minus 1. So the total, the result is n times a n minus 1, which is actually, if you think of it, the derivative of this function at the point A. So that's how we get this limit, and that's how we prove that the derivative of this function has this shape.